With its two facilities in Vienna and Gotz, Siemens Transportation Systems is one of the world's leading suppliers of railway rolling stock, with a special focus on metro cars, passenger coaches, and bogies. For more than 150 years, the company has developed, constructed, and finished components and complete vehicles for local and long-distance rail traffic. Here in Vienna, trams and streetcars are also repaired, an area where the company continues to press ahead with programs that completely rebuild this kind of rolling stock. Up-to-date technology and standardized design are especially important to the company's customers. In order to handle the increased workload on cars and coaches, SLF was commissioned to erect a new building for prep work and a combined spray booth and drying cabin. In order to be able to accommodate all types of rail cars, the cabins have an impressive construction length of 32 meters. This view of the newly erected building shows the dismantling hall on the left, the prep cabin in the middle, and the spray booth with integrated dryer on the right. Today, the early shift ends with sanding work performed on the empty carriages. Fresh air can be targeted at the various work areas by means of interconnected sections. With a system in place to renew the air 18 times an hour, all of the dust created by the work process is removed, whereby the majority of sanding particles are already extracted right at the machine. The sanding tools can be docked at 10 connection points. The extraction system in the left and right side walls provides for the extraction of air and particles using integrated filters. Amply dimensioned lighting fixtures mounted on the ceiling and walls uniformly illuminate the work area at more than 900 lux. A pneumatically powered lift platform has been placed on each side of the rail car in order to ensure that workers have good access to all areas of the car. The passenger compartments are then placed in the coating cabin using a remote-controlled lift truck. Access to the cabin is through a 5-meter-high rolling gate made of lightweight metal. The buildings here do have their own rail connection, but in the case of such basic work, the bogies are processed separately. Because the floor's entire surface can be put under load, the carriage supports, which only have a small load-bearing footprint, can remain in place during the shunting process. This is due above all to the heavy load impact separators, which have replaced the graded floors previously used in spray cabins. Just like the prep area, the spray cabin is 32 meters long and has a large in-ceiling filter, which handles up to 50,000 cubic meters of air per hour. The first step in the work process is to blow away impurities from the cars to create a perfect coating surface. These long fluorescent lamps illuminate every level of the work area at 1,000 lux. In this hall, the elevated work platforms travel along 28-meter tracks and have scissor-like extenders for varying their distance from the wall. These platforms can extend between cars by up to 2,810 millimeters to allow work on the ends of the cars. Masking is also performed on cars slated to receive more than one color of paint. The cabin is switched into coating mode from the control cabinet. Because operators occasionally use the touch panel while wearing their work gloves, a somewhat unattractive but protective foil has been applied to the screen. The sectional ventilation system is extremely important for the work that now follows. The entire room is divided into 10 work areas that are controlled by a sensor-based operator recognition system. Because of this, it is not necessary to constantly replace the room's entire volume of air with heated and filtered fresh air. Controlling the louvers in the air supply ducts above the cabin and opening the appropriate number of in-floor louvers beneath the impact separators causes the vertical flow of air to entrain the overspray. But because the air flows only where it is actually used, this system achieves energy savings of 70%. The operator recognition system switches on a group of 3 filter cassettes, so that a floating zone of fresh air always accompanies the operator as he proceeds with his work. If the work requires a specific arrangement of zones, these can also be selected manually. This method of operator-dependent sectional ventilation is a patented process. The use of the impact separators also achieves significant savings by reducing maintenance costs for the filter mats by 80%. The replacement intervals for saturated filter mats here are significantly longer. Only the smallest and lightest of the entrained particles must still be captured by the downstream filter mats. The route taken by the overspray airstream allows the entrained paint particles to precipitate out in a vortex-like zone of turbulence. The dried paint collects on an easy-to-dispose-of foil. Because the surfaces of the impact separators also collect overspray, they are equipped with an easy-to-exchange protective metal plate. Coating technicians with paint on their shoes also soil this walkway, the maintenance of which was made much easier in this cabin. Our so-called quick clean foil is held down on the floor through underpressure, created by an in-floor duct connected to the suction side of the exhaust air system. Once soiled, the foil can be removed and replaced. This solution eliminates encrusted flooring. The two coating technicians have first applied the filler and primer layers. Here in this cabin, only water-based coatings are used. In order to achieve good surface coverage, a preset humidity level must be maintained at all working temperatures. The machinery room therefore contains a humidifier which processes 50,000 cubic meters of incoming cabin air per hour. The unit uses normal city water from the municipal water supply. Because this closed-loop system handles a huge volume of air, we see that this installation is also equipped with an ultraviolet sterilization system. A gas burner is especially efficient at supplying the heat required for the coating and subsequent drying process. A large plate heat exchanger also provides for a favorable energy balance. Incoming air and exhaust air flow through pure aluminum cassettes, which ensure that the heat loss is minimized when blowing clean air out through the roof. The design of the two work platforms chosen for this installation is especially well suited to the needs of the coating technician. The overhead light sources eliminate shadows, foot switches for controlling lateral movement keep the technician's hands free, and the travel speed of 9.5 meters per minute is well matched to the application. Once the coating process is finished, the drying time is set. The ventilation system is automatically placed in recirculated air mode, and the cabin temperature is raised to the desired level. A special exhaust air line is used to release only those solvents freed during this process to the outside environment. A comparison of the average operating costs for this spray cabin and a conventionally equipped cabin of equal size used in the same way as our cabin here in Vienna brings the issue of savings right to the point. Filter replacement, cleaning costs, heating and maintenance costs, in short, all personnel and all material-related costs amount to an annual savings of 108,428 euros. The SLF concept has reduced operating costs, which once amounted to 237,497 euros, to just 129,069 euros. How about your company? Are you ready to cut costs too?